Okay, let's try some naming. Nice thing about these is they tell you exactly what kind they are. These are formulas for ionic. Ionic are always, always, always a metal to a non-metal. Some people wrote some notes that said no prefixes. What we have to do, though, is balance oxidation numbers, which means the crisscross method. So, systematically going about these, potassium, I find it, it's K with a +1 charge at the top. Chloride is Cl with a -1. That is a match made in heaven. KCl is potassium chloride. Calcium, it's Ca with a +2. Sulfur, a -2. You don't crisscross these. This is a match made in heaven. +2, -2, perfect. CaS, one of those to one of those, and they are happy. Now when we get to magnesium and bromine, we've got an Mg who has a +2. Bromine only has a -1. You can't make magnesium happy with just one bromine. It's going to take two bromines and only one MgBr2. I don't write the Mg1 just in much the same way. Nobody writes H2O1. It's simply H2O. If there's only one of them, you just leave it. Calcium, iodide. Calcium, also +2. Iodide, also -1. Crisscross, CaI2. The molecular portion of our program is a different rule. They are going to need prefixes. Those prefixes, now I got to find them. Are they here? Of course they are. They're right here. Those prefixes are down here. These are only used for molecular formulas. So when I'm looking at these ones, I have to look at those prefixes, and they just simply tell me how many. Disulfur is S2. Trichloride. Chloride is on the nonmetal side, it's Cl, and we put a 3 next to it. Hexanitrogen. Nitrogen is N, and according to this, hexa means 6. So I put an N6. Phosphide. Phosphorus is P. Tetra means 4. Deca. I think there was supposed to be an M there. Br is bromine. There's 10 of them. Dicarbide. Carbon, carbide. That means that there's 2 of them. Hepta is 7. There's 7 of something, whatever selenium is, which is Se. Octa is 8. That means 8 iodines to make iodide. This way, it's just the other way. Part of this is a little bit easier. One thing to notice, when these things are ionic, when we're naming these, ionic, no prefixes. We don't need the prefixes. We simply tell the name of the metal, and then the name of the nonmetal, and we end it with "ide." Ends, both of these, ends with "ide," ends with "ide." But a big difference is the moleculars, the ones I'm writing now, will have prefixes. So I'm doing some ionics. No prefixes, ends with "ide." Mg3. I don't say tri. It's simply magnesium, and phosphorus becomes phosphide. No prefixes, because there's only one way they can go together based on their charges. K is potassium. I is iodine, so that is on the nonmetal ide side, so it becomes iodide. B is beryllium. F is fluorine, so it'll become fluoride. Just that simple. No prefixes on ionic. Molecular, also simple as long as we remember prefixes. Wait, do we have to remember it? We shouldn't have to if we wrote it on our, well, it's written on our periodic table, but it's written down here. We just got to be able to recall those prefixes. N is nitrogen. B is bromine or bromide. but I have to have prefixes. 7 is heptanitrogen. 3 is tribromide. Tetra. Where am I getting this? Well, 4, according to this, 4 is tetra. Tetrasilicon. I don't change the first name at all. It's only the last name that becomes ide. Octa, iodide. The last name ends with ide. C is carbon. P2. Let's see. 2 is di. P is phosphorus, so that will become phos. It'll actually become phosphide or phosphoride. Either way. Why no mono? It doesn't belong there, and it's just one of those rules we remember, almost like when we see CO2 or CO. That's carbon dioxide or carbon monoxide. It's never monocarbon dioxide or monocarbon dioxide. Yeah. Next one's endothermic or exo. Is the heat exiting? Well, if a hunter opens a package, heat exits, that's exothermic. But if we use a cold pack that get cold, that means that heat is going into it and it feels cold because it's taking away. It's endothermic. If the heat is exiting on the product side, well, that's exothermic. But if the heat is over here on the reactant, almost as if we need to put it in before it'll work, it's endothermic. Home stretch, balancing some equations. I'm going to do it. I'm going to put a line underneath every arrow. That way I can count up what's going on. I need to balance mg's, fe's, and o's on this side. mg's, fe's, and o's. I put it in the same order so that I can go down the line and compare. First things first, count up what is there already. 1 mg, 2 fe's, and 3 o's versus 1 mg, 1 fe, and 1 o on the right-hand side. Figure out something that doesn't match. Well, the oxygens don't. You can't start with 3 oxygens and only have 1 when you're done. So if you're going to break them all apart and restructure them, you're going to need at least 3 of those. But once you write a 3 there, that's a coefficient, you have to recount the magnesiums and recount the oxygens. That fixed my oxygen situation. The other situations aren't good yet. For instance, I only have 1 Fe on this side, but somehow 2 on this side. You can't start with 2 and only end with 1. So I'm going to need to end with at least 1 more. And that is now balanced. Finally, you can't end up with 3 magnesiums if you only started with 1. So we must put a 3 there so that we have 3. 3, 2, 3. 3, 2, 3 matches 3, 2, 3. That's now balanced. Next one's PBs, S's, and O's versus PBs, S's, and O's. Hey, they go in the same order on that side. 1 of those, 1 of those, and 4 of those. I see 1 of those, and 3 plus 2 is 5. So there's no real perfect way of fixing this, but one thing I can tell you for sure, you can't start with 4 oxygens and end up with 5. So we must have started with more of these things than just 1. Next higher number is 2. Put a 2 there and recount. Now I have 2 PBs and 2 S's. 2 times 4 is 8 oxygens. So going down the line, 228 versus 115. Doesn't seem like I did much, but the next step will help a lot. If I have 2 and 2 on this side, but only 1 and 1, let me try to fix that by putting a 2 there. Recount 2 of these and 2 of these. When I now go 2 times 3 to get 6 and add it to those 2, I have 8. 2, 2, 8, 2, 2, 8. Now it's balanced. I love the next one because if I count up H's, S's, and O's, H's, S's, and O's, on this side I see 2 of these, 1 of these, and 1 plus 3 is 4 of those. On this side I see 2 of these, 1 of these, and 4 of those. I don't have to write anything for these. Some people will. They'll write, I'm going to just get rid of some junk. Some people will write 1, 1, 1. I'm okay with that. Isn't necessary. That is a correct answer. It is balanced, just as is. Last one. I'm counting NAs, BRs, H's, and watch this. I'm going to count PO4s as one thing instead of P's and O's because they stick together. So I'm going to NA, BR, H's, and PO4s. No sense counting extra stuff. 1, 1, 3 H's, and 1 PO4. 3 of these, 1 PO4, an H, and a BR. What to fix first? I will shoot for H's on the right side because I have 3 on the left. You can't start with 3 and only end with 1. You at least need to end with 3. Recount the H's, but also recount the BRs. Well, that fixed those, but now my NAs and BRs on the right, there's too many. You can't start with 1 NA and end up with 3 NAs. So we must need a 3 there because you at least have to start with 3. Put a 3 there. That also changes the BRs to 3. 3, 3, 3, 1 versus 3, 3, 3, 1. That is balanced, and that's our app.